Hi everyone, welcome back to the second part of this tutorial. Just to recap, what we're going to create now is a data-driven gradient based on the location where you are on Earth and the current temperature, current weather. So we get all this information and we create an amazing gradient that changes depending on where you are and the current temperature. So let's jump back in. We are in Cables, we are here. So this is where we stopped in the previous video. We called this, we made those like small nodes here that basically calls the OpenWeather data website, and we get our current location based of your own geolocation, our API key, and that's it basically. In this node here, we have the output. This is how in the Celsius, you can also change in the API to use imperial, but I would strongly suggest that you use Celsius because it's more logical. So we have this particular number, but we need to map this number to a color. And how do we do that? And as what I said in the previous video is we use a color map. So there's a tons of different color maps out there. A good article would be this one. This is like was published in Towards Data Science, which is a pretty cool Medium publication. And basically, this is a whole article talking about how you map color data to colors. And you are very familiar with this. If each map that you look, if you have things colored like this, as a co-plef map, for instance, here you change the background of the region according to some values, right? You also have very annoying color maps like this one, which is like the basic color map in MATLAB and was used also previously in Python. This is a very bad color map. We can have another video just to talk about the theory behind colors. But today, what I would like to do is to take a cool color map and like what I mean by cool, meaning that it's perceptually linear, so you don't have any distortion artifacts that comes from the color map itself, as you can see here maybe on your screen. It seems like the yellow is very bright and the blue, like the cyan here, is very bright too. And it should not, because if the value goes from 0 to 1, like all the values in between should be smooth and linear. But here it seems that we have spikes in lightness and hue. And compared to those ones like Viridis, heat, or magma, or everything here seems very smooth between the lower end here and the high end values. So I really like this magma color map. So what I did was to go on so these guys invented those color maps are in the Matplotlib core team. So the guys behind the most popular visualization library in Python. So, and the code is open source. So what I did was to go on the GitHub for Matplotlib and get the values from this particular color map and import them in Cables. So don't worry, I will share the patch, so if you do not have to do the whole thing yourself. But basically what I did was to get the values and let me paste the node here. This is just a string editor as we saw, as we used here. So let me put it back here, string editor. And here inside of it, let me show you that. You have all the values, like normalized value, R, G, and B, red, green, and blue values from 0 to 1 for all this particular color map. So what you see here, this magma color map, the values are here in this file. Okay, so I will share the node so you don't have to type it yourself in the description below. So we have the colors, and just notice that I put this as a JSON file because this is also the way we format arrays in JSON with the square braces. So and the output here is a JSON object, but for now it's still a string because this is a string editor. So I need a way to convert this in a JSON object. So let me put this here. If you want to annotate also your code, you can do that. You can press tab, search for the comment up, it's very big. And let's write this, open API. Maybe, I don't know, this is our main loop. This is what we're gonna do after to drive the visual. So main loop. Okay, up. And the third part of our patch here would be the color map. Okay, so we're here. Still, this is just a string value. So we need to, even though the editor knows it in JSON, the output is string. So I need to transform to parse it with what we call parsing to transform the string into like a real object. So fortunately, there's an op for that, which is called parse int array object. Parses a string to a JSON object, exactly what I need. Parse object, connect the two nodes, and now I can inspect the object again, and as you can see, it's all formatted. So, and Cables here tells me that it is valid, so that it is really a JSON object and is like there's no errors. Pretty cool. Now I have it. I'm cool. I have the values as a JSON object. Now, what I didn't tell you before is that most of the things that are happening in Cables works with arrays. I told you this in the like 2 videos ago when I told you that to look at the array category here, and I told you it was the biggest category in all Cables, right? You have like, I don't know, hundreds of ops working with arrays. So this is exactly what we have here. This is they call it an object, but it's really an array, the type of an array. So there's a way to convert an object to an array, and the op is has a very crazy name, object to array. Cast an object port to an array port. So basically, this is what it does. Because I know that even though this is a JavaScript object, I know that it's already formatted as an array. So I can just cast it, transform this object to an array. And now when I open it, doesn't seem very different, but look at the colors here. Now the output is this light purple, maybe, yeah, here. And this is an array. This is what I will need as an output to really do stuff with Cables. So now I have this object to array, and I have my color map. Now, if you want to work with color maps or any colors in WebGL, because remember that Cables is based on WebGL, the colors are not an array, there's not like different arrays, sorry. What you need to, if you want to work with colors, positions, scales, or everything, is to put everything into a flat array. So there's not, if you look it up here again, you see that this is an array, and each section or each index of this particular array, there's another array here. So you have like square braces, and inside are those square braces. What we need now is to have only one array, and to flatten everything into one array. And basically what WebGL would do was to read 3 values by 3 values, 3 or 4 values depending on what it is, by 3 values. For instance, for positions, if I have 3 points, instead of having one array and each time in this array I have 3 small arrays for each coordinate of each point, you have only one array, and you put 9 values for 3 values for point 0, 3 value for point 1, and 3 value for point 2. So we have an array of 9 values, which will represent 3 points of 3 coordinates. Okay, maybe watch the video again if that's not very clear. This is basically how it works, because it's faster to read. You just read one big array and you chunk it into different number of values, because you expect it to be a packet of 3 values, basically a chunk of 3 values, because we work in 3D. For colors, sometimes it's 4 values because you have RGB and the alpha value again. But here, we don't need that. What we need here is to flatten this array into just one big array of 3 values. So there's an app for that, which is called Flatten array. So now if I connect it here, this array is going to be 3 times as long as the previous one. You see, check it out. This is 256 values, and this is 768. And as you can see here, everything is flattened into one big array. But it's okay, because Cables and WebGL knows that they need to be read 3 by 3 values. So basically here we have our color map, and it's ready to be used. Now what we need is to map this particular temperature to our color map. So what do I mean by that? Think of this. Maybe I should start by showing you the color map, but we already have it here. Imagine that this is 0 and this is 1. We need to define for us what would be the lowest temperature that we can expect. Is it 0 degrees? Is it minus 100 degrees? We don't really know. It's up to the user to define. So this will be our like left bound, and the maximum value, maximum temperature. Maybe it's 30 degrees in your country, maybe it's 50 degrees, maybe it's 70 degrees, which is pretty hot in your country. So we need to map values and say, this is the minimum value that I can have, and I associate the minimum value with, I don't know, this black color, and the maximum value would be this bright white, but it's not even white, but bright yellow, and this will be 50 degrees. And then, depending on where I am with my current temperature, basically I will pick one color in between. This is December now, so it will be probably in the lower end values. I live in the North Hemisphere, so probably around here. And of course, we need to do that automatically, right? So let's get back to our color map. I hope that you get the idea of what is to map values to colors, and then basically we pick the value in between, and we will get the final color. So how do we do that? For just to change the color of the background, remember that we need to put the clear color node. So let me put this here, connect it. I can play around with the colors, but this particular, this has been defined by me randomly. These numbers now need to come from the color map and the value that we have here. So we need to involve this particular part of the patch and this one as well to change the value of this clear color. So a very useful operation that we have in data visualization, for instance in D3, the library, or any other node visual programming system, it's called a mapping range. It's a node that basically takes a range here, maps a value from one range into another. So remember that I said that we need to define what is our lowest temperature, our highest temperature, and then associate this to colors. So I have my map range here, and I can start by defining, okay, the colors here, and the value is the where we go where we pick the value in the original old min old max range. So this is my temperature. I'm going to connect it here. And the old min, I say, okay, my minimum value would be, I don't know, minus 5 degrees. And my maximum value that I can encounter here, I don't know, in Paris, would be 40 degrees. Okay, so this is my temperature range. Now my output, and this is where the new values that we need to take into account. What we have here is an array that, before we flattened it, that has 256 values. Right? So we need a way to go inside this array, the different position, according to where we are in our temperature. So maybe I will need to map this from 0 to 255 values. But what I don't like to do is this, I put the numbers. I mean, if I change my color map and now I only have 128 values or 5 values, this is going to break, right? Because this is not linked automatically. So what I could do is to automatically get the size of my color map and then map the values so that I can make sure that I can only change the old minimum, so the values that I have on my region, the maximum, lower end, and maximum values, and don't really take into account the size of the color map. This has to be done automatically. So let me go again. I have my value, my array here. I need to take a size. I know from this particular output that we have 256 values. But to have the number itself, there is an operator that does it, which is called array length, which would give me the number of values, 256, which is good. Remember that here we start numbers at 0, so it means that I can go from 0 to 255. So here, this number here is 1, it's too big from one value. So it's okay, I can just, subtract something from it, just one value. Because this is a number now, it's just give me the size. I can connect it. By default, the other value is 1, so I subtract 1, and now I can go from 0 to 255. And now what should I do? I can maybe map the values, right? I know here that my minimum would be 0, the left part of my color map here. And here I have 200, the end map, the end value would be the index to 255, right? So I have 256 values inside, which I can pick to transform my color, my value, my temperature into a color. So here I take this as an output. I go here and say, new max. So now automatically the size of my color map is mapped to the range that I need. Okay, so let's see what the result is. So here, when I put the current temperature, which is 11 and 85 degrees Celsius, look at what I have as an output. It tells me, you need to go to index 95.48. So this is the exact value that I need to get the colors in between in the color map. The thing is, as you know, here I only have 256 values, so I can only go from value 0, value 1. I cannot really go in value 95.48. It doesn't exist. It's not in between the two values. So I will need another math operation, which is called an interpolation, which will tell me, okay, give me the value in between index 95 and index 96, and at actually 48% in between the two. Right, so there's an operator that does it automatically, which is called an interpolator. And let me just type it here: interpolate number array. So basically now here, so this is the index where I should pick the color at 95.483, which doesn't really exist in my color map. But if I interpolate the numbers, now, if I take the array on my color map here, and I need to multiply this by 3, because don't forget that now this is all flattened, so it's 3 numbers each time. Multiply by 3, right? Because the array, once again, this is flattened, so we have three times more colors because we go RGB1, RGB2, RGB3. So if I multiply this by 3, this is like the new index that I get from this flattened array. I can put it here, and now I have I need to pick the values at index 86, 286.45. And because this is actually an array 3, I could do this for the R value. I could put this would be like for the B value and the G value, but this is a bit annoying, like to go from pick just the R value at this index, the next add 1 and take the blue value, and add 1, add the green value. I'm sorry, the green and the blue value. This is not very optimal. So there's another interpolator, which is called interpolate numbers array 3. And now by default, Cable knows that the array that we put here as an input is an array 3. So we can can jump 3 by 3 values. So make it dead. Maybe put this here. Take the flattened array here, and now automatically I get what they call XYZ, but in our case this is R, G, and B value. So let me connect this in the clear color. Okay, sorry. And I have this dark purple, which makes sense. If I go back here, it's only 13 degrees, so it should be around here. To make sure that it works, let's change the range of our temperature. If I lower the maximum value, if I said in Paris, temperature can never go above 20 degrees, then if everything goes right, which it doesn't, so I did something wrong here. Yeah, okay, sorry about that. Because I use an interpolate number 3, I don't need to multiply the range by 3, because automatically this knows that you have to go 3 by 3. So sorry, this is why I needed to remove it. So let me go again. I put 40, I have this purple. Now if I put 20, it means that now, because I have, it's almost 12 degrees. 12 degrees is almost, it's reaching 20 degrees, but my minus value, my left value is -5. So I have actually 25 degrees of differences. If I put 0 as my minimum value, we go towards this, the middle of the color map. Now if I put, let me go back here and put, I don't know, 15 degrees as the maximum value, we go closer to the final value at the end. You see, we are at index 200 out of 256. If I put 12, we are almost at the end. And if I put 11.95, we basically reach the last value from the color map. So put it back again. Say it's maximum 30 degrees in Paris, which is not true, but -5 as the minimum. So now we go left, we go here towards the beginning. Once again, if I change my maximum value and my minimum value and say, no, actually in Paris, I remember it was -20. So now if it's -20, it means that actually we are going back to the middle, right? Because the black value here is -20 and 12 degrees, it should be like here. So, this is how you can make the user select the values, like the range of the values, and it also depends on your current location. So instead of having to change all these numbers by hand, it's cool, you can slide it, but it would be even better if the user could change it automatically from the patch itself. So to do that, I need to introduce new sets of nodes, which belong to the sidebar menu. So here, sidebar overlay to control values. That's exactly what we need. Let me put it here, sidebar. And you see that automatically what it does, it creates a new div, an HTML div on top of our canvas here. And by default, there's nothing in it, right? It's just called sidebar. Maybe we can call it controls. You can click it to be minimized by default. So you need to click to open it, for instance. Is it visible? Yes. Now what we need, we have this sidebar, is to create some sliders to be able to move our minimum value and maximum value. So there's a slider element. And what we need, once again, to work this up needs to be child of sidebar. So you connect it. And I have a slider. I can rename it. Maybe I would call it minimum temperature. And so this is my minimum temperature. I would say my minimum is, I don't know, the range should be between -20 and 0 or I don't know, 5 degrees. So it can never be lower than 5 degrees. Okay, for instance. The steps should be, I don't know, 1 by 1. You don't really need to take care of this. You can change, keep the default value. Say, the minimum is 0, this by default. So by default, this is what the slider would be, and you can, scroll it to go back to -20 degrees or 5 degrees. And I need the same slider, Control C, Control V, for the maximum value. I can connect it like this. Call it max temperature. And say, no, the minimum should be at least 10 degrees, and the maximum is 50. Okay, and the default is 40. Okay, so these are my minimum and maximum values. So from that, here the second parameter of the slider is the actual value that you have, from the slider. So I need to connect it to my range here. So I can, put this here, try to make it clean like this, and now change my old min and old max with these values. So I can put it there and connect that here again, save my patch, and now automatically I can play with these parameters. So if I go here to the left, the range is bigger. So if I can go up to minimum of -20 degrees, of course, now being 13 degrees or 12 degrees in Paris, is going to be closer to the right side of our color map, right? On the other hand, if I just put it up, and then of course, the more I increase the temperature, if the minimum temperature is 5 and it's 11 degrees here, it's going to be very on the left side of this color map, so more like a dark purple, almost black value, what we see here. So basically, we are done for this part. But I remember at the beginning I said, well, it's going to be a gradient. Here it's not a gradient, this is just a plain color. But this color is based on your current location, a color map, and the minimum and maximum temperature that you can input. Now, if I want to have a gradient, I need two other values, right? If you take a gradient with three values, what we could do is take the minimum value for the day, the maximum value for the day, and see where we are in the middle, right? So if you are closer to the night, it's going to be colder at night, like most probably. But so automatically the gradient will change during the day. Okay, so let's do that. It's not that easy. It's not that difficult now that we have everything we need. We basically need to do the same operation with the map range for the minimum value of the day and the maximum value of the day. And we need to get those values from the Ajax request, so from the API. Automatically, this was actually given. I didn't, so we can just go back here and inspect the object, and have the daily part of the answer, saying, okay, this is the daily values, and the first object daily is a number as an array, because this will actually give you 8 values for today, the next day, till the end of next week, till next week. So if you just take the first value of the daily array, you actually have here in temperature, you have the minimum of the day and the maximum of the day. You can choose the night, the eve, the morning, the day. This is the average temperature. So you can put any of those values and drive the gradient from these values. So I would leave this maybe as an exercise for you to do. And I'll see you in the next video. But maybe before that, if you want to see the whole color map, because here we took this one and we are always, we need to go back and switch to the website. It would be cool if we could just see the whole color map ourselves, right? So there's a way to do that, but I need to introduce new operators. So this will be part 3 of this video. See you in the next part.